Hello there. We are a team of researchers at INESC TEC Center for Robotics in Industry and Intelligent Systems, and we want to show you the stack we've developed to ease the development of scalable industrial robotic systems. Let's go. Inside each of INESC TEC's robots, there's an instance of the Task Manager running. Task Manager is a ROS package responsible for orchestrating the execution of robotic tasks. Each robotic task consists of a sequence of robotic skills. Robotic skills are modular and reusable blocks of software built upon ROS actions, able to perform well-defined operations like drive operations. Robotic tasks are represented as SCXML files and are parsed by the task manager that converts them into instances of ROS SMAC. Upon user instructions, execution of tasks is requested by an advanced plant model, also known as APM. When the task manager receives the APM request, it starts executing the smash state machine, controlling the execution of each skill according to the flow defined in the SCXML file. The task manager starts by sending the goal to the drive skill that triggers the robot's movements until the desired location. Once reached, the task manager will move on to the next skill and so on. The APM communicates via an IoT platform with a robot and also with enterprise-level systems, such as MES, Manufacturing Execution Systems, or ERPs, Enterprise Resource Planners. The advanced plant model uses information obtained during the execution of robotic skills to maintain a digital twin of the physical environment where the robot is working. That way, all robots get to know the real state of their environment and can cooperate. To create, execute, and monitor the execution of robotic tasks, a stack of web-based technologies was developed. The skill generator allows the complete development of robotic skills to be used by robotic units. All skills are stored as Docker images in a private Docker registry. Skill generation is aided by CI/CD mechanisms, which ensures proper working of the skill. The CI/CD stack validates every change to existing software, as well as new tasks or skills developed by the other tools. It uses a modified version of ROS Industrial Continuous Integration Stack that allows building our code stack and executing both unit and integration tests and simulation tests using AWS RoboMaker, while also using other Amazon services for a smooth integration with the CI/CD pipeline. The task creator lets you assemble and edit existing robotic tasks using a simple graphical user interface. It also allows you to send the developed tasks directly to the APM for later execution. Runtime monitorization of skills execution is also possible. To generate a skill, the skill generator requires some information, such as the skill name, server language, goals, outcomes, feedback, and results. The skills are deployed to a Docker registry. Thus, the user must provide a registry to which the skill will be deployed. It is also possible to configure either system libraries or private repositories as dependencies, which will then be installed in the built image. The skill generator supports access to private dependencies by using SSH key files. Once all the parameters are inserted, the skill configuration is successfully finished. After the skill configuration, it is possible to generate the skill, which is composed by the several ROS packages. The default behavior of the generated skill can be altered by editing the code of the server. After reaching the desired behavior, the Docker image for the skill is built with all the dependencies installed. Once the skill's Docker image is built, it can be pushed to the configured registry. After the Docker image is built and the skill is committed to its repository, the CI/CD process is triggered. The first step is to build our application and execute its unit and integration tests using the ROS Industrial Continuous Integration Stack. If the build and tests are successful, the bundles to be used on our AWS RoboMaker simulations are created and uploaded to an AWS S3 bucket. The AWS step function state machine is triggered. The generated skill was deployed with success to our private Docker registry and can now be downloaded by robots. State machine is responsible for the execution, monitoring, and analysis of the AWS RoboMaker simulations being executed. We use AWS RoboMaker World Forge to create various scenarios where we can test our new developed skill. After all the simulation jobs are finished and the analysis returns a successful execution, our state machine is executed with success. Since our state machine returned a successful simulation execution, our CI pipeline passes with success. Task Creator is a development environment built to facilitate the construction of robotic tasks. In this video, a task corresponding to a drive and bin picking operation is being developed. First, it is required to include the required robotic skills to complete the task, such as drive skills, move arm skills, robotic ripper skills, as well as some initial and final states. Afterwards, the different states must be connected in order to complete the robotic task and thus achieve the desired behavior. Finally, the parameterization of the skill goal is done. For example, for the drive skill with the ID drive rack 1, we configure the location in a trajectory where the robot should head to. The transitions between the different states may also be configured in order to achieve the correct sequence of operations. Once finished, the task can be sent to the advanced plant model responsible for triggering the execution of the tasks according to the production schedule. The tasks can also be exported as SCXML file and later be imported by the task creator for revision. With a created task now in APM, we can plan and execute these tasks to both our real and simulated robots. APM sent the previously created task to our robots. Our previously developed drive skill is used in this use case to drive to a rack for bin picking. Our simulated robot executes multiple pick and place tasks, picking parts from the rack and placing them on their box. Our real robot can execute the same task as in simulation, picking and placing the same parts in their box. APM shows that all the steps of the task were executed successfully. The APM also updates the digital twin representation in real time according to the task being executed.